All right. Okay, so this presentation is entitled Game Technology and Open Source, because your wallet just isn't that fat. It's a hopeful title. I'm afraid I'm going to have to admit that it's not actually in the long run. There's not so much hope. I'm Nathan McKenzie, and that's the take home if you want to leave now. So I'm Nathan McKenzie. I actually have a startup here in town entitled Ice Cream Breakfast, where we work on educational game prototypes. Okay, so to give you a little more about myself and why you might want to listen to me if you want to, I got into the commercial game industry back in 1997. I worked at Raven Software and Rainbow Studios on titles including Soldier of Fortune, Heretic 2, Take No Prisoners, Quake 4, some prototype Xbox 360 games, and just typical commercial fare. Additionally, though, and kind of the genesis of this specific presentation, last year I spent a full year working for the military evaluating the current state of open source game engines in comparison to commercial off-the-shelf engines, as well as just basically the whole ecosystem of, if you want to make a game, what are you looking at? They like the idea of open source. They like the idea of having control and not paying. Who wouldn't, right? So I spent a year looking over this stuff. They had different needs than what I think most educators need, but the research I think kind of applies pretty well across the board. So can I ask for a show of hands of anybody who works in any way making content that's digital, that's used for kind of multimedia-ish or game-related or any of those things? Okay, I was afraid of the amount of teacher hands up that I was going to say. I have a presentation that was way over the heads of everybody in the room. It'll just be half the people, which is probably acceptable. I'll try to be kind. So, what is a game engine? In case you're not really familiar, a game engine is really the programming underneath the game that makes it go, and it's often common programming. So, if you remember Super Mario Brothers, code for the mushroom maybe is not game engine code, but code to make gravity work. That might show up in another game. That's something you might want to get for free when you get a game engine. Okay, so basically a game engine, you need that. You really want a game, right, or some sort of educational whatever, but you're going to need that engine to make it. It's worth keeping in mind too, though, that a game engine isn't just can we put bump mapping, or can we put shiny walls, or can we put real-time lighting on the screen. A game engine is also what mediates really your whole process. So a game engine is also how your texture artists or how your modelers or how your level designers interface with the computer and make stuff. And so it's not just a feature list. There's also this whole process that comes with it. So in this presentation, it's really kind of two or three parts, depending on how fast I talk. I'm going to talk first about this question of, all right, fine, you want to make a game. How do you evaluate these things? It's a really, really complicated question. And as I worked for the military, I found that more than saying this game is like this, or this engine is like this engine is like that, the real question is, how do you know that you're measuring what you're getting in a useful way? I'm not sure that I got the best answer ever, but I hope that it's at least a little bit insightful. So I'm going to go over three different paradigms of looking at game engines, and I'm going to show why it's incredibly difficult to decompose game engines into pieces, which is where the open source world works. And there will probably be copious references to iPods. And then I'm going to talk about what exactly is out there. What are the choices? Once we have this framework, what are the choices for what you could select? And finally, I'm just going to cover, fine, okay, there's all this information. Clearly, there's lots of people making technology. Clearly, most people are having a hard time at best, crashing and burning at worst. Making games is really difficult. So what's going on? Why can't we get this right? And I will say probably ultimately that it's just hard, but I hope you'll understand why it's hard. Okay, so let's talk about the first paradigm that you could use for analyzing engines, and this is the standard one, oddly enough. This is kind of a system perspective or a functional perspective. So, for example, to get the ball rolling here, graphics rendering. You buy an engine, you expect it to put pictures on a screen. That's part of what makes it exciting and appealing, of course. And so this is kind of, I'd say, paradigmatic, that's maybe not a word, but of this whole kind of genre of kind of a functional decomposition. You look at things of the engine lets me put stuff on the screen, or the engine lets me make sound. And so the interesting thing about this, we've got input handling, we've got world simulation. Can you make the objects interact and do stuff over time and have that make sense? Collision detection. If you've got objects knocking into each other, do they just pass through each other? Do they do useful things? Do they resemble real objects? Animation. You've got things that have internal bones and human bodies or dogs or whatever. Can the engine make that work? Artificial intelligence. You've got creatures in the world that are ostensibly smart. Can they navigate around the world? The thing that's interesting is that if you look at marketing or how people talk about game engines, this is how they talk. And the other thing that's enormously interesting is everybody, by this kind of metric, does the same thing. Everybody has all the same features. But it's clear that using different engines doesn't result in the same outcome. So this isn't necessarily a useful way to look at games. It's a necessary, maybe, way to look at the engines and what you're getting, but it's not a sufficient way to look at them. Okay, so I'm going to move on to another way of looking at game engines that's equally important. And this is along content lines. And so this is kind of the devil of game engines. If you talk about, say, terrain, this is a specific type of thing we model in game engines, rolling land that has curves to it. In general, it has properties that are important for how you draw stuff, and it has properties that are important about physics simulations, and it has properties that are important about networking. And basically, if you want your engine to run well at all, not use too much memory, and be able to do stuff in real time, your terrain has to actually affect a bunch of different systems. So what does that mean? It means that if you want terrain, you're probably not going to be able to glue it into a bunch of different modules at once. This will be a theme, and it's going to reflect on why open source maybe makes a lot of trouble. Or isn't coming together as well as it could. Another example, foliage and grass has traditionally been extremely difficult to get into game engines. If you want a nice, lush garden, you better be ready to do a lot of special things that are not just the generic put some random, triangles on the screen. Buildings. Building complexes, which ironically enough have different properties for speed purposes in game engines. Characters, which include, of course, hedgehogs and occasionally people. They have their own set of properties, faces, like we saw in Half-Life 2. Vehicles are another common thing. Special effects rendering. And the thing that's interesting about these categories is that they are not at all supported equally across different game engines. But they're not talked about quite as much. They are sometimes, but in general, it's not the same kind of paradigm. These are types of things that you do in game engines that need special kind of support. But it gets honestly worse and also less pictureful. So there's also this concept of game features. So these are things that cut across all boundaries, and I would describe them almost like cracks in a dam. That if you have a dam, if it has any cracks, you don't have a dam anymore, really. What you have is water coming out of a dam and then nothing, right? So unfortunately, there's a lot of game features that if they're not supported in every single bit of code, you don't have that feature. So some examples of these are multi-threading, which is very complicated, but it's basically the ability for a machine to take a task, break it in two, and have multiple sub-machines do it at once. It's really hard, and if you don't do it right, your game crashes. Some engines support it, some don't. Special hardware support. So either your whole engine works on the PlayStation 2, or you don't have a PlayStation 2 game. Either the whole engine works on the Nintendo DS, or you don't have a Nintendo DS game. Once again, this is not something that modularization supports very comfortably. Streaming, which if you've seen Gears of War or some other recent games, there's this technique where there's no load times. People just play and things just happen. Well, that's complicated and involves special features that the engines in their entirety have to support. Saving and loading, being able to pause the game, go have lunch, come back, pick up where you left off. Once again, you can't pick up where you left off if only part of the world is how it was. Database integration, networking, what libraries are used, the tools, which I'll talk about more in a little bit, and scripting language support, which makes it easier for less experienced programmers to make things work. So that's quite a list, and it's, again, very pictureless. But these things are really, really important. These are the things that you don't know that you need, that halfway through a project you suddenly discover that you do need because that one game that you wanted to copy does have, and the engine that you picked that was economical doesn't have. Suddenly you discover all your programmers are spending all their time implementing these things. Okay, so these are kind of three ways of looking at the world. And as mentioned, I think the first one's the one that's looked at or kind of focused on most, but you can't actually throw any of these three out. If you do, you'll be burned by it when you discover that you shouldn't have thrown it out. So let's look at some examples of what you can make stuff with. So commercial engines, and we've already seen some of these today. There's Unreal Engine 3.0 now, very beautiful. Half-Life 2, which we've seen, also very beautiful. Doom 3, beautiful but very dark. And I have to say, too, when I was getting pictures for this slideshow, I was going through and it was all fine. And then I finally got to the commercial engine part. And all of a sudden, all the random pictures that I grabbed were so violent that I thought, oh, wait a second, I need to pay attention to these random pictures I'm putting in because I'm about to put something really horrific in the middle of the screen. So I had to work a little bit to make this sanitary. And then finally, the Torque engine, which the guys at Filament are using, and which is much lower cost. The thing that's interesting about all of these engines is that in some ways they're much like, say, the iPod. They're deeply integrated, they're well designed, they know how all the features fit together, they remove duplication, they're very clean. They know the process of you starting a game, coming up with what content you need, and having a toolpath and code to get that content into the game. They're also incredibly expert-focused. They expect that you have incredibly expensive software and that you also know how to use that incredibly expensive software to put stuff into the world. For those reasons, they're not actually all that ideal for a lot of educational game makers who maybe aren't great experts about making this kind of content. It would be like if I sold any of you a Japanese typewriter, you wouldn't be ready to make the Japanese novel unless you knew the Japanese. You have the tool, but you don't have the skill. And this is it's a really difficult problem because game engine makers don't have a whole lot of incentive. They're busy trying to, in an arms race, trying to outcompete each other. They don't have an incentive to make an on-ramp for people who may